In this lesson, we will be discussing formulas and how we might manipulate those formulas in order to fit our situation. Here are some basic formulas that you've seen in elementary school or maybe middle school, um, such as distance equals rate divided by time, or area equals length times width. Now, wouldn't it be much simpler if we were wanting to find the rate if we simply knew that the rate was going to be equal to the distance times the time, or say we were looking for the width of a certain rectangle or something, that we wanted to find W is equal to the area divided by the length. Now, knowing that ahead of time, if we knew the area and the length, then it'd be very quick to be able to find the width. So that's kind of the motivation behind what we're learning today. So the process of changing these around is called transforming these formulas or equations. This means to solve for a particular variable within an equation or formula while staying in terms of the other variables and constants given. Now, for example, like what we just talked about, we had area equals length times width. Now, if I wanted to solve for W, then basically I'm just solving just like a normal equation. I'm going to divide by the L so I can get rid of that. And so I'm left with area over length is going to be equal to W. Now, I said saying in terms of the other variables and constants given. What was given to us was the area and the length and the width. And so therefore, we still have the area and the length and the width, and that's it. Nothing extra came in and nothing left. Okay, so we still have our constants and our variables there. Okay, now, so a couple of real examples, actually three. We're going to start with example one, that we're going to be transforming the geometric formula of volume, and we're going to be solving for W, just like we kind of just did. Okay, so in this equation, we've got volume equals length times width times height. Okay, so this is just simple multiplication. Okay, so in order to solve for volume, for width, we need to get rid of this length and height. Now, how do we normally get rid of coefficients or other numbers being multiplied together? We usually divide. Okay, so I'm going to divide by length and height. Okay, but if I do it on this side, I need to do it on the other side as well. So I need to divide by length and height there as well. Okay, so the length cancels off, the height cancels off, and I'm left with volume divided by length times height is going to be equal to width. Okay, and so very quickly I could change that around and say that W equals volume divided by length times height. Okay, and so that very quickly transforms this formula around so that, let's say that I was given a volume problem where I was given the volume, given the length, given the height, and told to solve to find the width. And in that case, it would help me a lot to know that the width was going to be equal to the volume divided by the length times height. So there's a very quick example of how this could apply. Now, we'll move on down to example 2. And this time we're going to be transforming equations. Okay, we just transformed a formula, but an equation is very similar to a formula because you still got variables and constants, and so it's very similar. But usually we end up with y equals something. So a lot of times um, it's tempting just to leave it like that, but sometimes it helps us to know how to solve for x. Now it really does come in handy, especially when you start learning rules like substitution, things like that, learning how to solve for a variable. So we're going to take this equation, y equals 4x minus 3, okay, and we're solving for x. In other words, we're trying to get x by itself, okay. So if you pretended like this was just a number, then this would look like a normal equation like you've seen it anyways. So we're going to treat it kind of like that, okay? So I'm trying to get x by itself, so the easiest thing to get rid of would be this minus 3. It's kind of like the backwards order of operations that we're used to. So we add 3 to both sides. Okay, so that's gone. All right, now I'm left with y plus 3 equals 4x. Okay, so now in order to get x by itself, I need to divide both sides by 4. Okay, so that's gone. and I'm left with this on one side equals x, okay? And then if we want to go ahead and simplify that, we could have y over 4, or y divided by 4 plus 3/4 if we wanted to split that up, or you could say 1/4 y, either way, okay? But basically we found x to be exactly, to be in terms of what we were given. We've got our constants that may have changed around a little bit because we've had to move them over to the other side, but in general, our constants are there, our variables are there, and so therefore our final answer is there with x equal to y plus 3 over 4 if we want it that way, or we could also write this as 1/4 y plus 3/4. It kind of just depends on what your teacher prefers there. I would prefer this personally. Okay, so moving on to example 3, and this will be our last example. This time we're going to be transforming equations containing only variables. Okay, so this time just imagine that there's no constants whatsoever, but we've got a ton of variables, and that doesn't actually change anything about the way we approach the problem. We want to take this problem and we're going to, it says solve for b, so we're going to get rid of this z as if it was a constant, and we're going to get rid of that r as if it was a constant, and we're going to move it over here, okay, just like we always have. Okay, so I'm going to take this and rewrite my problem. Okay, I like to write a z with a little line through it just so I can make sure I'm not writing a 2. Okay, yeah, b times r equals p. Okay, so the first thing I would do is I would subtract this z. Okay, so minus z on that side. All right, so I'm left with negative br equals p minus z. Okay, now if I want b by itself, that means I also don't want that negative. So if I've got b times r, I need to divide by r, but don't forget to divide by that negative as well. Okay, so we can get rid of that. Okay, so that r's gone, that negative's gone. Divide the other side by the same thing. Okay, we're left with b equals p minus z divided by negative r. Okay, and very straightforward formula there if you're looking for b in this situation. So if you found out the values for p, z, and r, then you can very quickly just plug those in and find what your value for b was. So that would be your formula for b. Okay, and many of the problems that we're going to be doing from here on may have pictures, or they may not. They may just simply be variables, or they may have variables and constants. But the principles are the same. You just simply take what's given to you. Don't be discouraged by variables or constants either way, and just use your simple principles of backwards order of operations and solve for a particular variable. When you're solving for that variable, you will end up with that variable on one side equal to something on the other side that is this, all it is the same variables and constants that was in the rest of the problem to begin with. Okay, and so you're ready to do some examples on your own.